Hello, my dear first PUC students. How are you all? I welcome all my first PUC dear science students to the best learning platform, that is the Teacher app. Yes, students. So, how is your colorful journey going on? Yes, it's already began, right? So you already are introduced to all the new courses that you have choose like PCMB, PCMC or PCME. So I hope your journey will be beautiful, colorful and successful. Yes, our teacher platform definitely is going to help you in all the ways possible to make your first PUC and second PUC journey the most successful, right? For your next coming professional courses, definitely this 2 years of your PUC, you know it is very important along with the entrance exams like CET, JEE or NEET. You all have so many dreams to achieve and go out with a colorful as a doctors or scientists or engineers, right? So to make your dreams come true, this teacher platform is definitely going to help you in lot many ways, my dear students. So I am Meghana, your chemistry lecturer. So I have done last sessions about the basic concepts of organic chemistry that you all have to know. As I told you, the organic chemistry is the most wanted concept when you are studying chemistry. Okay? All the basic things you study under organic chemistry is going to help you in many ways. So in the last session, if you listen to my videos, I have explained you what is hybridization, how what is sigma bond, what is pi bond, how the sigma and pi bond is formed. So what are hydrocarbons? So all the basic concepts you can check out in the first session of basic organic chemistry chapter. And also, let's continue with the today's session. My dear students, I have brought in front of you a very important basic concepts. So I hope you listen and you go through the video completely for a better understanding, my dear students. So let's start. Yes. So organic chemistry, some basic principles and techniques that you have to know. In that, the first topic I have brought today in front of you is a bond line representation of any organic compounds. Students, see, organic compounds means, especially in organic chemistry, we study about, for example, if we are studying about hydrocarbons. What are hydrocarbons? It is basically bonds between carbon and hydrogen, right? So it can be further classified as alkanes, alkenes, alkynes, correct? So these, for example, let me take simple compounds like alkenes. Okay, I will take particularly ethane. So what is ethane? It is nothing but two carbon atom. So if I write the structure of ethane as CH3, CH3, got it? So maybe you are a bit confused. What is this CH3 CH3? To understand, let me write. You know that the carbon atom should have four valence bonds, four bonds satisfied, right? So the next carbon atom also has four bonds. Now each three hydrogens form covalent bond here and here also carbon hydrogen covalent bond you can observe. So this structure what I have written in short, maybe in short I have written as CH3 CH3. That means this is known as this ethane. The structure of these ethane, I will call this as complete structure, whereas the short way of representing ethane as CH3 bond CH3, this I will call it as condensed structure. Is that clear, my dear students? So first we can represent any structures or any organic compound in a complete form or as well as in the condensed form. Now let me give one more example. Now what if I take a condensed structure, that is CH3 COCH3. Okay, so the whatever I have written in front of you is the condensed structure of an organic compound. So now I'll be asking you to write the complete structure of this organic compound. So you have to see to that when you're writing the complete structure, the each carbon atom should be satisfied with 4 covalent bonds. Is that clear? So now I'll write CH3 as, yes, 1 bond, 2, 3. Now the next bond is with the carbon atom. Right. Now you observe this carbon atom is further attached to third carbon atom, and third carbon also has 3 hydrogen atoms covalently bonded. Now, the first carbon atom is satisfied with 4 bonds. 1, 2, 3, 4. Yes. The second carbon atom is satisfied with 4 bonds. 1, 2, 3, 4. Yes. Whereas the middle carbon atom, the second one, has 1, 2 covalently bonded to 2 carbon atoms. So, definitely it should be a double bond with the oxygen atom. The second carbon forms double bond with the oxygen atom. So, now it is completely a complete structure of the organic compound. What organic compound it is? So all that you will definitely be studying in the further concepts. Is that clear? So apart from once this complete and condensed structure is clear for you all, apart from this we have one more way of representing the compounds, that is known as bond line structure. So students, bond line structure is nothing but it is zigzag way of representing the organic compounds. For example, let me put a structure in front of you. See, so you'll be seeing amazing. What is this? What is this ma'am has written? Is this an organic compound she has written? What kind of structure is this? So you'll all be thinking of it, right? Yes, students, it is nothing but I can call this as butane. Do you believe? Can you believe that this is butane? Yes, you have to believe. This is a simple form of representing organic compounds. So, how to organize this? How to understand this structure? Yes, definitely, I'll be helping you. So, students, what you have to understand when a bond line structure is given to you like this, the terminal part, you can see the ends 1, 2, 3, 4. Are you able to understand? So the ends where the line joins, the corners represent the carbon atom. Each corners represent one carbon atom. Is that clear? Each corner represents the carbon atom. So here you can see 1, 2, 3, 4. So it is 4 carbon atoms. 1, 2, 3, 4 carbon atom. And the next point what you have to understand, the terminal carbon atom represents methyl group. The terminal carbon atom represents CH3 group, methyl group. So which is the terminal here? Here this terminal carbon atom, and here the terminal represents CH3. So the terminal, the end carbon atom should be methyl group. So when the end one represents methyl group, definitely the middle one, if you see, the middle carbon atom already has 2 bonds. The remaining 2 will be hydrogen. So it is CH2. So this carbon also already has 2 bonds, and the remaining 2 will be hydrogen, CH2. So this part represents CH2 and this part also represents CH2. So what is this CH3, CH2, CH2, CH3? Yes, it is nothing but butane. Understood? So this butane structure in bond line form I can just represent like this. Is that clear, my dear students? So this is how we represent organic compounds in bond line structure. So now I'll put an example in front of you. I hope you'll be able to write the bond line structure for it. Okay. Um, so what is this, my dear students? Are you able to make out the structure? Yes, so you can, how many corners you can see? One, 2, 3, 4, 5, 6. So how many carbon atoms? It is 1, 2, 3, 4, 5, 6 carbon atom. So terminal one, that is, this is the terminal carbon, this is the terminal carbon has methyl group, that is CH3, and the remaining carbon atoms has CH2 groups. So it is CH3, CH2, total how many carbons? 6 carbon atoms. So what do you name it as? Yes, it is nothing but it is a hexane, right? So hope it is clear for you all. So let me give one more example. So this is bondline representation of which compound? Can you guess? Yes, it is 2-bromobutane. Yeah. So you will write it the terminal one as CH3, correct? The middle carbon CH2 it has to be, but it is bonded to bromine atom. The third one CH2 and fourth one CH3. Yes, students, this compound is the bromine atom is attached to second carbon atom, so it is known as 2-bromobutane. Is that clear? So this is a bond line representation of any organic compound. Not only this compounds, even the cyclic compounds also. See, for example, here students, the cyclic compound also you can represent in a bond line form. Now can you able to predict the structure? See here, the terminal groups has methyl part in it, and you know that these carbon atoms is CH2, 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 CH2. So count the number of carbon atoms. Yes, it is 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms. And to the third carbon atom, so you can see here, to the third carbon atom methyl group is attached, so it is known as 3-methyl octane. Now, even the cyclic compounds can be represented in a bond line form like this. So, you know that I will write propane as CH3, CH2, CH3. If I write a cyclic structure, it will be CH2, CH2, CH2. This is a cyclic representation which is known as cyclopropane. Now when I'm writing the bond line structure of cyclopropane, I'll just write like this, like a triangle form. So bond line representation, each corner indicates carbon atom with CH2 group. So you can observe here what is a cyclic representation of cyclopentane, right? This is about the bond line structure you all have to know, my dear students. Okay, so I hope this is clear for you all. Let's move on to the next concept. See, any organic compounds, there's so many examples I given, like it can be alkanes, alkenes, or alkynes. All the organic compounds, when you're seeing your teacher writing on the board or the way I'm representing here, is a two-dimensional form. Okay, but all the organic compounds you have to imagine in a three-dimensional form, dear students. That is in the space. So when you keep any organic compounds in space three-dimensionally, how it looks, that you should be able to make out, you should be able to imagine. So I will explain you how to represent any organic compound in three-dimensional bond. So we can, to represent the organic compound in three-dimensional form, you know that each carbon atom contains 4 covalent bonds, whereas I represent these bonds, one bond as solid wedge, okay, so the another bond as dashed wedge, the remaining two bonds with a normal line. Okay, so one with a solid wedge, one with a dashed wedge, remaining I will explain you with a normal line. So solid wedge I represent like this, a broad and then a narrow form. This is how I represent a solid wedge. Okay, it will be broad in first and goes and becomes narrow at the end. This is how I represent a solid wedge, my dear students. And dashed wedge I represent like this in the form of like this. I represent the dashed wedge. You can observe here. See, a solid wedge is represented this way and the dashed wedge is this way. Okay. So let me explain us. I'll take a simple organic compound, that is methane. I will represent in a three-dimensional form. Okay. For example, students, can you imagine, or can you imagine a symbol of our national emblem? So you know that our national emblem has four lion faces, right? So when you stand in front of a national emblem and see the symbol, are you able to see all the four faces together? No. You can see the first three faces, lion face, and the fourth face will be behind you, correct? Which you are not able to see. The three faces, one in towards you, and the remaining two to almost to the left and right, and the remaining one you can observe that is behind you. That will not be seen, right? So that is a way we represent organic compound. For example, so this is a two-dimensional paper I have. For example, imagine this is a sheet of paper. So what is this? This is a sheet of paper. So when I represent an organic compound, if this is a carbon atom, okay, if this is a carbon atom, one bond, one atom that is attached is towards you. So this atom is towards you. I will write it as A. Whereas the other two atoms is in the plane, which I represent it as B and C. Where is the one more atom? The another one you have to imagine behind. The D1 is behind the paper, which you cannot see. Understood? So one, if you are observing, you are an observer. For example, you are observing, this is your eyes. Okay, you are observing from here, you are looking from here. This A bond, this A atom A is towards you, whereas atom D that is attached to the carbon atom is behind you. Are you able to understand, my dear students? So how do I represent this compound that is towards you, and how do you know this is exactly towards you and this is exactly behind you? So this you will come to know through solid wedge and dashed wedge representation. A compound that I have taken here is methane. So observe, my dear students, if I write the carbon atom, okay, so if I represent one hydrogen atom with a solid wedge and the another hydrogen atom with a dashed wedge and the remaining two in the plane with the normal lines. So what you have to make out from here? So if you are an observer observing from here, the hydrogen atom that is represented with the solid wedge is towards you, directly towards your face, and the remaining two hydrogen atom is in the plane of the paper, and this hydrogen that is represented through dashed wedge is behind the carbon atom. It is or behind you. Okay, so that will not be seen, it is behind you. So the towards the observer is represented, towards the observer is represented through solid wedge, where the any molecule or a atom that is away from the observer is represented through dashed wedge. So this is the three-dimensional representation of any organic compound. So once you have understood how to represent the organic compound in three-dimensional form, and also the writing the condensed, complete and bond line structure of organic compound, students, now we come to the very important point of the concept, that is classification of organic compound. So how can you classify organic compounds? So there are several way of representing organic compounds, classifying organic compounds. So one by one we shall discuss. So listen carefully. and go through all the examples that I am giving to you, my dear students. Okay. So first of all, organic compounds can be classified into open chain. The simple way I will tell you, that is a open chain organic compound and closed or a ring compound. So another way of expressing it is acyclic compounds and cyclic compounds. Okay. Now first let me give an example for what is acyclic or open chain compounds, cyclic or closed compounds. Otherwise I can, when it is cyclic, it means it is in a ring form. Okay. Now if I write examples like this, CH3 ethane, or I write CH2 double bond CH2 ethine, or if I write huge compounds like CH3 CH2 COH alcohol. So when I represent ethane, butane, propane, pentane, any or alkenes or alkynes, when I represent the compound in a straight chain like this, it means it is not in a cyclic form, it is a open chain compounds, or otherwise these compounds what I gave example here is acyclic compound. That means representing a compound in a straight chain. Okay. Whereas if I write example like this, cyclopropane, what is this? This is cyclopropane, or cyclohexane. What is this, my dear students? Cyclohexane. Or if it is an aromatic compounds like benzene ring. So all these you can see that they have a cyclic structure. So they come under cyclic or closed or ring compounds. So now it is clear for you, right? Acyclic compounds and cyclic compounds, it's exactly the opposite. Acyclic compounds will not have a cyclic form, or it is not a closed chain, it is an open structure, whereas cyclic compound is a closed chain. Now if you take a cyclic compounds again it can be classified as alicyclic and aromatic compounds. Okay. In the cyclic compounds only, the acyclic, cyclic, open chain, closed chain. Now I have taken only the closed chain compounds. Okay, or a ring compounds. Now this closed chain or a cyclic compounds is further classified into alicyclic compounds and aromatic compounds. Under that, homocyclic, heterocyclic, here also benzenoid compounds, non-benzenoid compounds, and heterocyclic compounds. So one by one, let me explain you. Okay. Now, for example, let us see what is homocyclic compounds. Students, the name homocyclic here, homo means same. That means same atoms. Whereas hetero means different. Okay. Homo means same. Hetero means different. Homocyclic compounds, see, I will put some examples in front of you. Cyclopropane, cyclobutane, cyclopentane, or cyclohexane. So how do you make out the structure of this compounds? As I told you in the bond line form, each end, each corner represents carbon atom CH2, 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 CH2. Now how do you write the structure of cyclopentane? It is nothing but CH2, CH2. So everywhere it is CH2, that is it is only carbon atoms, right? It is only the carbon atom and the hydrogen atoms that take parts in the formation of bond. Apart from carbon and hydrogen atom, you will not be able to see any other atoms there. So it is called as homocyclic compound. Whereas what is heterocyclic compound? Now I shall put one example in front of you. So what is this? Here students, this is nothing but this is the oxygen atom. I call this compound as tetrahydrofuran. Okay, it is tetrahydrofuran. this compound you can see, yes, each corner represents CH2, this represents CH2, here this represents CH2, CH2 where this is oxygen atom. So apart from carbon and hydrogen, the other elements like oxygen, nitrogen, sulfur, so any other element take part in the formation of the ring, then these compounds we call it as heterocyclic compounds. Is it clear, my dear students? I hope you all understood what is homocyclic and heterocyclic compounds. Now, let's move on to the aromatic compound. Students, what is aromatic compound? Aroma. Do you know what is the meaning of aroma? Yes, it is a good fragrance or smell. Most of the aromatic compounds has good aroma. So otherwise, the another way of explaining you all the aromatic compounds means definitely it will have a alternate double bonds or a benzene kind of compounds, especially we call them as aromatic compounds, but we cannot stick into for that information only. We can classify this aromatic compounds further as benzenoid compounds, non-benzenoid compounds and heterocyclic compounds. So as the name says, what is benzenoid compound? So any compound which goes with the benzene ring like structure, which has a benzene ring in it. Okay, so the family of benzene we can tell. Okay, benzene is the first member of the family if we consider the all other compounds which comes under the benzene family, okay, which follows the benzene structure, we can call it as benzenoid compounds. A lot of aromatic benzenoid compounds are there, my dear students. See, for example, if I write a benzene ring, you all know what is benzene ring, C6H6, that is cyclic ring with alternate double bonds. So this is benzene, whereas two benzene rings, this is naphthalene, okay, or so many examples I can give to you all. To the benzene ring, if any halogen atom is attached, this is called chlorobenzene. Fine. So to the benzene ring, if acid group COOH is attached, this is called benzoic acid. So all these compounds, derivatives of benzene anta helbodu. So the derivatives of benzene is known as benzenoid compounds, okay, which has a benzene structure in it. Whereas what is non-benzenoid compound? It looks like a benzene, but it is not a benzene ring actually. Let me put an example for non-benzenoid compound. Analyze that, dear students. So analyze this example, everyone. So how do you think this is a benzene structure? Can you make out, is it a benzene or what it is? If you count the number of carbon atoms, you will come to know whether it is a benzene or not. Okay. So let's count the number of carbon atom. 1, 2, 3, 4, 5, 6, 7. It has 7 carbon atoms, 7 ring, or that is a heptane ring I can call you. So this is not a, it has alternate double bond, but this is not a benzene ring kind of structure because it has a heptane structure. So this comes under, this is known as, specially known as tropolone. This compound tropolone is an example for home non-benzenoid compound. So in the aromatic compound only we can also see heterocyclic compounds. Heterocyclic compounds under aromatic. So I can call it as heterocyclic aromatic compounds which will be having alternate double bonds. So now I am going to give you some examples for heterocyclic aromatic compounds. Okay, for example, Yes, it will be having six membered structure, but here if you observe, this compound is known as pyridine, where you can see that all the six carbon atoms, if it is there, it is a benzene ring, whereas here it is CH2, 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 whereas one nitrogen atom is involved in the formation of the ring, so which comes under heterocyclic aromatic compound. So one more example I can put for you for a heterocyclic or aromatic compound. For example, here if you observe, there is an alternate double bond, but along with the carbon atoms, oxygen atom is involved in the formation of the ring, so this is known as furan. So this is also a heterocyclic aromatic compound. Is that clear, my dear students? So you can classify the compounds into acyclic or aromatic, acyclic, cyclic, aromatic, inaromatic, benzenoid, non-benzenoid, heterocyclic compounds. Again, you can classify aromatic compounds as aromatic and non-aromatic compounds. See, so these are the some of the classification you all have to understand. Is that clear, my dear students? So once we are dealing with the complete chapter, you will come to know about all the compounds, and then you should start analyzing which is aliphatic, which is aromatic, which is acyclic, which is cyclic, or aromatic, non-aromatic, benzenoid, non-benzenoid. All that you will be able to recall when we are dealing with more and more examples in further classes. So after this kind of huge classification, let us understand some of the functional groups that is involved in making lot many organic compounds. Okay, so what is this functional groups? So students, apart from hydrocarbons like alkanes, alkenes, alkynes, we have functional groups that is bonded to the hydrocarbons to form more and more different organic compounds that is useful, very much useful in our daily life. So I want to discuss with you all some of the important functional groups. Okay. Now for example, if I take a simple compound that is methane. Methane means you all know that carbon atom bonded to four hydrogen atom, we call it as methane. Now what I do, uh, since carbon atom is covalently bonded to four carbon atoms, remove any one of the hydrogen, okay, and add any group, like for example I will add halogens. For example, I will add chlorine. What are halogens, my dear students? Halogens means it is group 17 elements like fluorine, chlorine, bromine, iodine. We call them as halogens. So what happened? The formula CH4, that is methane hydrocarbon, is now turned into CH3Cl, that is chloromethane. So these we call it as halogen compounds. Is that clear? So we get haloalkanes like this. So alkanes is now turned into haloalkanes. Is that clear, my dear students? Not only a simple example I've given. For example, if C2H6 is ethane, what I do, if I replace any one of the hydrogen atom with halogen, for example, C2H5Br. So C2H5Br, I call it as bromomethane. So this is a haloalkane compound. So this is one kind of organic compound you all have to know. Now the next one, I will come to the functional group, that is alcohol. So what is alcohols, dear students? So alcohols are represented with a symbol OH. So if you find the OH group or hydroxyl group attached to carbon or hydrocarbons, we call it as alcohol functional group. The first functional group that you have to know is alcohol. it is represented as OH. Also, there are so many functional groups that you all have to know. For example, aldehydes, aldehydes represented as CHO, ketones, ketones represented as C double bond O, carboxylic acid, carboxylic acid which is represented as COOH. So lot many functional groups I need to introduce. First, in today's session, let us understand alcohol functional group, aldehydes, ketones, C double bond O and carboxylic acid. Now, as I told you in a halogen family, the same way. Now, CH3, CH2, instead of one hydrogen, I will replace with OH group, alcohol functional group. So what is this? There is a OH group, that is alcohol functional group, and the two carbon atoms are there. So I can call it as ethane. You know that it was ethane. So what I'll do in ethane, I will erase this E part, okay? The last E I will erase, and for alcohol I will add the suffix OL. So what is the suffix I add? OL. So it gives me ethanol. Okay. The same way, if I represent, if CHO, otherwise I write it as C double bond OH, which is otherwise known as CHO, which is represents the aldehyde functional group. So students, here I have to count this as carbon 1, this is carbon 2, both the carbons I should count. Totally 2 carbon atoms. Yes, 2 carbon atoms means it is ethane. So since it is aldehyde functional group, for aldehyde at the last suffix I will represent it as Al. So it is ethanal. Whereas if you find a compounds like this, CH3, C double bond O CH3, you can find the functional group C double bond O here. So what this C double bond O functional group indicates? It indicates ketone. So totally how many carbons you can find here? 3 carbon atoms. So it is propane. Last E I will not write. The suffix I will add ONE. So I will call it as propanone. Okay. Whereas if you find a compound like this, CH3, C double bond OH, see C double bond O, it's not ketone, completely you see this part, COOH, which is carboxylic acid. The what suffix I add for carboxylic acid is here, yes, it is 2 carbon atoms. Again, I will write ethane. I will not write the last E. I will write it as oic acid as a suffix. So it is ethanoic acid. So some of the major functional groups like halogen atoms, when it is attached to hydrocarbons, we call it as haloalkanes, whereas alcohols is represented by OH and aldehydes represented as C double bond OH, ketones represented as C double bond O, whereas carboxylic acid COOH. These functional groups form bonds with the hydrocarbons and gives different types of organic compound with a very different chemical properties, my dear students. Okay, so I've just given an introduction to you with some of the functional groups, whereas for you should, what you have to remember here is alcohols you will add the suffix ol, phenols means you will add suffix al. Okay, ketones you will add suffix one at the end, and whereas in carboxylic acid you add oic, oic acid at the end. So these functional groups must be clear for you all. So in the coming classes, further classes, I will introduce how to do the naming for this functional groups. Simple examples like ethanol, ethanal, or propanone or ethanoic acid or any other organic compound is given. So how to name these organic compounds? You have to know, which we study under nomenclature. Nomenclature means in chemistry language it is called as nomenclature. Otherwise, simple way I can tell you, naming ceremony of the organic compound. So any new organic compound is found, you have to name the organic compound, give a specific name, right? So the students, the specific name should be in such a way, any corner of the world you go, the it should be the same. Everyone must be able to recognize that organic compound. It's not that we represent organic compound in our own language. We cannot represent or name the organic compound in our own kind of language. Okay, so worldwide we have to follow the same type of nomenclature, which is known as IUPAC nomenclature, that is International Union of Pure and Applied Chemistry. The system of nomenclature is known as IUPAC nomenclature. In further classes I will give complete picture about all the functional groups and how to name this functional groups. Is that clear? And not only I just told you, replacing one hydrogen atom with the functional group, and always it will not be only one hydrogen atom. You can replace n number of hydrogen atoms, any hydrogen, 1 2 or 3 or all the 4 hydrogen atoms. Okay, and it will give us a polyfunctional compounds. Is that clear, my dear students? So when I come to you in the next session, before that, what must be thorough for you all is how to name the organic compounds containing halogens like chloro, fluoro or bromo or iodo. How to name the organic compound containing alcohol functional group. How to name the organic compound containing aldehyde functional group, and how to name the organic compound containing ketone functional group, or how to name the organic compound containing carboxylic acid functional group. So how to name it, you should know what suffix you will add, then definitely the naming part will be easy. For alcohol, the suffix you will add is ol. For aldehyde, you will add the suffix al. For ketone, you will add the suffix one. And for carboxylic acid, you will add the suffix oic acid. So this part, if it is thorough for you all, you can name the functional groups with the number of taking into count the number of carbon atoms. So how do you take into count the number of carbon atoms? So if it is one carbon atom, you will write it as meth. Right, two carbon atom, you will count it and write it as eth. Whereas three carbon atom, you will write it as prop. So it goes on like that, students. Four carbon atom but. So this much idea I have given in this session. So combining all this information, it will be easy for us to give a nomenclature to any of the organic compounds, whether it is one functional group or polyfunctional group. Is that clear? So in today's session, we got a great knowledge of representing any organic compounds in a condensed form, complete form, and also a bond-line way of representation. So any compound is given to you, you should be able to represent those organic compounds in a bond-line form. Okay, and also the three-dimensional representation, very interesting, right? How the solid wedge and dash wedge can be used in the representation of organic compounds in three-dimensional form. And classification of organic compounds, what is acyclic, cyclic, aromatic, benzenoid, non-benzenoid, homocyclic and heterocyclic compounds is clear for you all, right, my dear students? And also I gave an introduction to the all the functional groups that is involved, that combines with the organic compound to give a different types of different chemical properties containing aromatic compounds. So along with this, I will finish today's session, and I'll be waiting for you all in the next session to discuss some more basic concepts of organic chemistry, which is very much necessary for you all for your further studies about the organic chemistry. I hope you all will be waiting for my next session, and I will end up this session. Thank you all for listening to me. Thank you, my dear students.